and that will be available to you either later tonight or always by the next morning. It takes my computer a while to process each one, and depends on how many I have during the day whether I can get them done by the evening or not. So, and then I will send a link to you as to how to look at that file. It's in a YouTube format. Basically, it just records everything that we say, and it records everything that you're seeing on my screen. Okay. All right. Go ahead and verbalize problem.
So my first question is, well, I have to factor expressions, but I haven't done this in a while, so it's a little.
Okay. Let's talk.
So I have 2x squared minus 6x minus 80.
Okay. Whenever you're factoring something, the very first thing you should always look for is, can I take a greatest common factor out?
Okay.
Can I in this
Yes.
problem, which is?
2.
Leaving?
X squared minus 3x minus 40.
Now, this is a much easier problem to factor, primarily because the coefficient of x squared is 1. Whenever you get the coefficient of your x squared term to be 1, it's usually what I call an elementary factoring problem. It doesn't require anything terribly sophisticated in the way of, I don't know if you've learned what's called the California method or the diamond method or just winging it. I'm a big fan of winging it myself. The way I do any factoring problem like that is I split the x's up, and I determine both signs. Both signs have to be what?
Negative, or negative and a positive.
There you go. They can't both be negative, otherwise that would be a positive number there.
Yeah.
And they can't both be positive. So one has to be plus, one has to be minus. So that's my step 2. Hold on, I got a little thingy here. Let me get rid of them. Okay. And then the next and final rule really is factors of 40 that subtract because of that negative sign to the number 3. Okay, well, finding factors is a bit of a trick. How do I find, can you think of factors of 40 that subtract to 3? Let's go ahead and find all the factors of 40. What's the next factors that I can do? In other words, I can cut 40 in half, and then of course I got to double that. Okay, I can cut it 20 in half. Got to still double that again. Well, I can cut 10 in half.
Yeah.
There you go. There's the 2 factors we're looking for, 5 and 8. Now, which goes where? The 8 goes with which sign, and the 5 goes with which sign?
The 5 goes with the addition, and the 8 goes with the negative.
Yeah, basically the rule I like to use is the larger of your factors, the 8, goes with the sign of the middle term. And it's as simple as that. It's 4 simple steps, okay? And you can do all first level factoring in this manner. And that's it. If you can always remember those 4 steps, you won't have any problems with any of them. Now, the moment you get a coefficient in front of the x squared term, it changes everything. Then that's what I call a second level factoring problem, which becomes more of a trial and error kind of problem. But since we were able to take the 2 out, we left ourselves a elementary quadratic, which factored rather easily. And then there's your final solution.
Okay.
I'm still learning this OneNote, excuse me. So what else you got?
I have 3x squared plus 7x plus 2.
All right, this is a second level quadratic. In other words, I'm not getting rid of that 3, right?
Right.
So the first two steps are still relatively the same. I'm going to break up 3x squared. How am I going to break it up?
Maybe just do 3x times x.
That's the only choice. In other words, you never leave the x squared in one spot. You always break up the x's, and the only factors of 3 are 3 and 1. So I could have written the x over here and 3x over there, but that doesn't matter much. Now, what are both signs?
Addition.
Yeah, they have to be, because that's a plus and that's a plus. So step 2 is exactly the same. And now, what are factors of 2?
1 and 2.
Yeah, so it's either going to be 2 and 1 or 1 and 2. One of those two choices. Which one produces a middle term that's the middle term that we have, which is 7x?
Three x plus 2 times x plus 1.
I'm going to erase that level right there. Now, how do we know this produces that middle term? Well, first of all, if I want to check to see if I factored it properly, you might think, well, we'll just FOIL this whole thing out and see if we get this. But you don't need to really go to all that work. We know that 3x squared is correct, and we know the 2 is correct. So the only term that's in doubt is the middle term. Well, how do you get the middle term? You get it from multiplying the 2 inside terms together and the 2 outside terms together, and then adding that together. Well, that gives you plus x. This gives you plus 6x. Add them together, you get plus 7x. That's our middle term, so we've factored it properly. And no matter what kind of quadratic you're factoring, this step is really a critical step. Even if it's an elementary one, even if we go back to the previous one, we'd always want to do this step to make sure that our middle term was correct. Okay?
Yeah.
So you always want to check the middle term. Okay? What else?
Hold on, I gotta look. I have 4x squared plus 4x plus 1.
Again, I cannot take a greatest common factor. But now I do have some choices. How do I want to break up the 4x squared? Because I can break it up as 4x times x, but I could also break it up as 2x times 2x.
Probably 2x plus or times 2x.
That's always a good first trial. Remember, we're dealing with trial and error. And what I tell everybody is always start with the factors that are closest together. Well, 2 and 2 is closer together than 4 and 1 is. Okay? Now, both signs, again, have to be positive. And there's not very many choices on 1. It's 1 and 1. Does that produce the proper middle term?
Yes.
Yeah, that's plus 2x. That's plus 2x. Add them together, you get 4x. Get used to doing that step. That's kind of what I call my double smiley faces method. because you're always doing it. No matter how simple or hard the quadratic is, this is the last step you're always doing to check to make sure you've done it correctly. Now, let's notice what happens if I try 4x and x. Well, everything else is the same, but here I get plus x plus 4x gives me plus 5x. So that can't be right. So if I would have started with 4x and 1x, I would have quickly found out that that can't be right. Okay. Now, what do you do if a number like 7, and you can't factor it?
I don't really know, because my teacher, he gave me this method that's supposed to work all the time.
The method that works all the time is the quadratic formula. That's the method, okay? In other words, whether it's factorable or not, the quadratic formula will always give you the answer. You know it by heart?
X equals, I used to. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Good. A lot of schools teach you a little song, memorize it.
Yeah.
And it's worth remembering because you're going to need to know this frequently. Okay? Now, if this was our quadratic, what's A, B, and C?
A is 4, B is 4, and C is 7.
So if I were substituting and I wanted to solve this particular quadratic, x would be what? In other words, every quadratic is going to have a solution.
Yes.
The easy ones are the ones you can factor. But if you can't factor it, you can still solve it. What you're doing is solving for the zeros of that quadratic. But if I plug it in to the quadratic formula, what's minus b?
Minus b is 4.
Minus 4. Plus or minus b squared is 4 squared minus 4 times 4 times 7 all over 2 times 4. Okay? And you'll notice that what's inside the radical sign is going to give me a negative number. Well, when you take the square root of negative numbers, you get imaginary numbers. So this is a quadratic that does not have real solutions, but it has imaginary solutions. And you've had imaginary numbers, have you, or have you not yet?
I don't think so.
Okay, it's probably why you haven't done much with the quadratic. They'll probably teach you imaginary numbers before they get very heavily into the quadratic formula. So we don't need to do any more on quadratics that can't be factored. Jeff, any more that can't be factored? How about something like this? You factor that?
Yes.
Into what?
X squared, or x minus 5 and x plus 5.
Yeah, that's called difference of perfect squares. Okay? And don't forget this one. That's also difference of perfect squares. In other words, that's x minus 1 times x plus 1.
Yeah.
Okay? What else you got? Now, let's see. Tonight, we've got like 10 minutes.
Yeah. Okay. I have 9u squared minus 9u plus 2.
Okay. Better hope it can be factored, because I can't take any greatest common factors. Where am I going to start?
You could do 3u and 3u.
It's always a good starting spot. What's both signs going to be?
An addition, or they're both going to be negative.
Correct. Now I've got to put a 2 there and a 1 there, and it doesn't matter if I put the 1 here and the 2 there, it's going to give me the same thing.
Mm-hmm.
Is that correct?
Yes.
Yeah, because that's minus 6u, that's minus 3u, that gives me minus 9u. Okay. Now, just backing up a second, if that was equal to 0, in other words, if we were solving an equation, what would our solutions
be? Your solution?
What's u?
In
other words, I have two things multiplied by one another that are equal to 0. Whenever that's the case, at least one of those things has to be 0. And the way you solve this is you set both of them equal to 0. In other words, one of my equations is 3u minus 2 equals 0. The other equation is 3u minus 1 equals 0. Well, when I solve this, I get u equal 2/3. When I solve this one, I get u equal 1/3. So there's the two solutions to the equation given by that. And what that means is that particular parabola, we know quadratics plot as parabolas, is going to go through, its two zeros are going to be at 1/3 and 2/3. When you solve a quadratic and you come up with a solution, as long as it started out equaling 0, then this is what you're solving for, are the zeros of that quadratic.
Mm-hmm.
Okay? Well.
So then I have 3x squared minus 16x plus 5.
Okay, so looks like it could be hard, but it's not really going to be hard because there's no greatest common factor. I can only split this up in one manner. What are both signs?
We have addition and, wait, no, we have a negative and a negative.
And it's either 5 here and 1 there, so I'll try that one. Or it's the reverse, 1 there and 5 there. Now, can you look at that and tell me which one it is?
The one that goes with the 3x is the 1 and the 5 goes with the x.
Yeah. So I will erase that. I'll erase that. And that's our answer because we get minus 1x minus 15x gives you minus 16x.
Cool.
Yeah, the ones that tend to be hard are problems like the following. Why is that hard? Because there's so many factors of 12, which means you have to pretty much try all of them until you find the one that works. And not only for this coefficient, but for this coefficient. So the difficult quadratics are the ones that have coefficients that are lots of factors. That's why I said that last one couldn't be that hard because 3 only has 2 factors and 5 only had 2 factors.
Mm-hmm.
Okay. Do you have another one?
See, I have...
Well, let me ask you, are you using a textbook?
No. I have a worksheet.
So it's going to be that way the whole year? All online stuff?
I think so. It's not... He made up the worksheets
Okay.
himself.
Nothing, that's fine. I was just curious if you had a textbook, whether it was the same one that I had. The one I have is the one in most common use in Colorado, but they're kind of getting away from textbooks. I'm probably more than half my students now don't use textbooks anymore. They either have online material that they cover, or the teacher just gives it to them.
Yeah. Okay. And then I have 2x cubed minus 50x.
First step.
So you could probably take away 2x, or yeah, 2x
Greatest
from
common factor. In other words, that's always your first step, is to see if there's a greatest common factor. Well, turns out that when you take away the greatest common factor, now you're looking at something quite simple.
Yeah.
In other words, cubics in general tend to be extremely tough to factor. If there's no greatest common factor, a cubic is like a 20-minute problem. It really is. You'll learn that in honors algebra, but not for a while. But compared to a quadratic is a piece of cake. Worst case scenario with a quadratic is you have to use the quadratic formula. But there's no cubic formula. If I stick a number on the end of that, like plus 17, now that there is no cubic formula that I can plug in to come up with the factors. It's a hugely difficult problem. So being able to pull out a 2x is great, because now how does this factor?
You could do 2x times x minus 5 times x plus 5.
So if all of that was equal to 0, what would the solutions be?
You would have 0, positive 5, and negative 5.
Very good. Most people forget the 0. They just do. So I'm glad you didn't. But again, what we're looking at is 3 things multiplied together equaling 0. The only way that's possible is if one of these 3 things is 0. So your solution is always to set all of them, each one of them, equal to 0 and solve it. Okay?
Yeah.
Got time for one more if you want to do one more.
I don't think I have any more left.
Okay, we don't have to do another. All right, Amber. Well, listen, it was nice having our first session. Did your mom tell you how to schedule sessions, or?
No, she just said to do it herself.
She would do it?
Yeah.
Okay. If on my website, which I'm spelling out for you here, you can actually, I use an online scheduler, which allows you to go in and schedule them on your own. Plus it does a number of things. You might want to visit that just to see more information about me. But I will let you and your mom talk it over, and I'll let her or you schedule the next one. Like I said, I will send you an email once this recording gets processed, and you can review it if you want. At least see how that process works.